Hi, welcome to my YouTube channel. Today we are going to discuss about the linear regression. In machine learning, we have three types of technique mainly. One is supervised learning technique and unsupervised learning technique and reinforcement learning technique. Linear regression is one of the supervised learning technique and it is a regression algorithm. In supervised learning technique, we have mainly two types. One is regression, another is classification. And now linear regression is a regression algorithm. For the supervised learning technique, we have output variables and input variables, nothing but input columns and output columns. For the unsupervised learning technique, we have only the input columns only, that is input features only. In the supervised learning technique, we have both input features and output features. For the output column, we call as like class or output variable or dependent variable. For the input features, we call as independent variable. So the main here we assume that statistical relationship between independent and dependent variable is the linear. What is linear is here. So the relationship between x and y is the linear. Linear is nothing but here we can see here the red line. So the blue color points are the points which are the actual points. The red color line is the predicted line. Okay, here the predicted point will be like here the predicted point. So the difference between the blue color that is the actual point and the predicted point is called the error or also called the residual. So the main aim is that we have to reduce the error. The error the difference between this actual point and predicted point. For this all this point we calculate by using the cost function. So this is the cost function formula. So the main aim is to minimize the cost function. For this we change the theta naught and we will derivative this cost function. So for that we use the another formula. Here we add the 2 here and we will use the derivative for this. Okay, to minimize the cost function we use this formula, and that is by updating the theta naught and theta 1 values. So without updating the theta naught and theta 1 value, we will use the convergence algorithm. That is like so here we can see here that this is the gradient descent graph algorithm graph. So whenever we change the slope theta naught is the constant, c theta naught and theta 1 values, so it will change. This is the last point is the global minimum, so we call it as a global minimum. Whenever the point reaches to the global minimum, error will be minimum. So for that purpose we we will convert the point will have to reach to the global minimum. For that we use this formula, repeat until convergence. This is the algorithm theta j equal to theta j minus dou by dou theta j of theta naught comma theta 1. This algorithm we will use. So whenever the alpha, instead of changing the theta naught and theta 1 value, will change only the alpha value. Whenever the alpha value here when alpha value is big, so it will jump to the large places like long places, and it will not reach to the global minimum. It will jump from here to here and here to here. It will not reach to the global minimum. whenever the alpha value is small, it will reach to the global minima, but it should take some time, and that is some disadvantage for here. So whenever it reaches to the global minima, the error will be, the main aim is minimize the cost function. Like this way we'll minimize and we'll find out the linear regression. Thank you.